Hello everyone. So today my topic is electric field intensity. Electric field intensity due to continuous charge distribution. Electric field intensity due to continuous charge distribution. So previously we discussed that we know Coulomb's law. What is a Coulomb's law? Coulomb's law, we can find out the force. The force equation is equal to 1 by 4 pi epsilon naught into q1 q2 by r square or distance square. So in this case we can find out the force on electric field point charge distribution. Force on electric field, force and electric field into the point distribution. For example, these are the one point will be considered. So these are the number of points will be considered. Each point it's creates some force. The force up to in electric field region. Each point some force. The force up to electric field region. So that will be discussion. So this point it possible to the continuous charge distribution. This point is possible to the continuous charge distribution. Thus the continuous charge distribution is nothing but the line charge distribution, line surface and volume. For example, these are the point charge. This point charge, they are the point charge. This point charge. So this point charge will be changes to continuous. Continuous point charge will be changes. So it will be consisting of a line charge. So whatever these are consisting of line charge. Similarly, this point charge we can change continuously in the shape of the surface. And similarly, we can change of volume. They are all particles, each part. Here consisting, we can observe here point charge. Number of point charges consisting of line. Number of point charges consisting of line. So this nothing is nothing but line charge distribution. Line charge distribution or line charge distribution and line charge density. Line charge density distribution, or we can call as line charge density. Similarly, this point are contained in the form of the surface. So it is also known as surface charge density. Similarly, this point in the form of volume. So when it's a form of volume, it is nothing but volume charge density. So line charge, surface charge and volume charge density. It will be indicating each part, we can indicating rho L, rho S, rho V. What is a rho? What is a rho? Rho is nothing but it is a radial distance. Radial distance in cylindrical coordinate system. Cylindrical coordinate system. For example, we can observe that we know the cylindrical coordinate system rho L. So these are the coordinate system. If it in case of cylindrical coordinate system, the variables or the elements are rho, pi, z. These are the cylindrical elements. So let us consider rho is nothing but it is a point. So the distance from origin to some point P. So some point, this other point is nothing but projecting point. So due to the projecting point, we can consider the completely, we can draw the circle. So this circle is nothing but the radial distance. radial distance. So for example, if we are taken to the line charge density. First we are consisting of line charge density. So for example, we are consisting line charge density. Very simple. So what is the rho? Rho is nothing but radial distance in a cylindrical coordinate system. So we are taken to the each and every part. So first one is the line charge density, surface charge density, volume charge density. So first we are taken to the line charge density. Line charge density. The point charge. What about this? This point charge continuously changes. So this point charge, the continuously changes, continuously moving from point A to point B. Somewhere consisting only finite length. So this point, for example, these are the point. What is the point charge? Point charge is equal to rho L. Point charge is equal to this point charge is nothing but rho L. But this point charge occupies some charge. So how much charge? These are the occupies the charge point. So this charge point we can consider of dq. This charge point we are consisting of dq. Similarly, this point charge dq we can draw bigger one thing. So what is the point charges? These are the point charges. Okay, so it is a form of line. From distance A to B. So each point charge. What is the point charge? This point charge is nothing but rho L. Nothing but it consisting of some rho distance. Line charge density up to some density will be there. So up to this density we are consisting of total dq. This point is nothing but small particle. Each small particles dq. Similarly, this length is we are consisting of dl. They are the charge. Up to this point is charge. Similarly, this point length we are consisting of length dl. So let us similarly length, differential length. So in cylindrical coordinate systems, what is the scaling factors? We know the scale factors. Scale factors in coordinate systems are Cartesian, cylindrical, spherical. In Cartesian, so scaling factors 1, 1, 1. But in cylindrical, rho, 1 rho. So why rho is? Because rho is coming to the picture. Here distance is depends upon the rho. The distance is depends upon the rho. So that case of we can write as small particle of charge dq. We are consisting of small particle of charge dq. This dq is equal to rho L into dl. These small particles we can write as rho L into dl. So what is the dq here? What is the dq? dq is equal to the charge element. The charge element. So dl is equal to distance. What is the length? The element length. Element length. So we can find out the line charge density. So line charge density, if it in case of electric field intensity due to continuous charge distribution. The continuous charge distributions are line, area and volume. The first case we are consisting of electric field intensity, continuous line charge density. Here continuous charge density, first case is line charge density. So line charge density we can find that dq is equal to rho L into dl. So we can find the electric field intensity. What is the electric field intensity? We know the formula for electric field intensity is equal to E is equal equal to 1 by 4 pi epsilon naught into q by r square, magnitude of r square with respect to ar unit vector. Let us, from the case of, these are the electric field intensity. Completely we have taken as electric field intensity. Electric field intensity is equal to force by coulomb, force by charge. Charge is equal to force by charge. Electric field intensity, we know the electric field intensity is equal to force per charge, Q. Nothing but Newton per coulomb or volt per coulomb. These are the definite units. Or force per coulomb or Newton per coulomb or volt per coulomb. They are the electric field intensity. Let us, from the case electric field intensity, right, for example this point is created at some point, anywhere of the point. At this point we can find out the electric field intensity. At this point we can find out the electric field intensity. So at the distance from point charge to each point charge to electric field intensity distance, this distance we are taken as r bar, the direction. So that is we are taken to the r. So we can find out the each, for example, each point. This point we have created some electric field. This point from created the electric field. We are taken to the every small particles. We can find out the electric field intensity. So that every small particle, every small point, we are taken to the differential. We are taken to the differential electric field intensity. So every differential is nothing but small part of thing. Anything of we are taken to the differential is a small point. So from the small point we are consisting of differential of electric field intensity. We are consisting Q. Q is also small part of charge, dq. So remaining are 4 pi epsilon naught r square into ar unit vector. We are consisting of ar unit vector. Let us, so completely how much area will be covered. So due to electric field intensity, dq is equal to what happened from the equation 1, dq is equal to rho L into dl. So dE is equal to dq plus rho L into dl by 4 pi epsilon naught r square into ar unit vector. So differentiation is transferred to opposite is equal to outside. So electric field intensity E is equal to integral of this differential shifted to is equal side of is equal sides. So rho L into dl 4 pi epsilon naught r square into ar unit vector. So what is it? This r is nothing but line. This electric field intensity consisting of line. This is due to what is this? These are continuous. This for finite. This for finite line charge. Line charge distribution. Line charge. These for finite line charge. So electric field intensity up to some finite charge distribute. Finite charge electric field intensity. This formula for finite charge electric field intensity. So up to we are consisting of only line charge density. If it in case of infinity line charge, we are consisting of some line A to B, some finite distance. If it in case of infinity charge distribution, then we will discuss the separate case. We will discuss the separating case. Up to here only line charge density. Okay. Similarly, the same concept. First one is completed line charge density, and second one area. Line is completed surface charge density. Second one is the surface charge density. Here rho L is equal to line charge density. Line charge density. Line charge density. Up to here, line charge density. So next we are consisting of surface charge density. So again we are consisting of surface charge density. So point charge, every point charge is created the some surface from surface. Okay, let us every point it create the, so they are consisting of surface. In this case, number of point charges, but as finally consisting of one surface. So number of point charges. These point charges were consisting of dq. Okay, so this point charge were consisting of dq. They are the sum one point. dq charge and distance is equal to dl. dq and dl. So it is consisting of each particle is some distance. So these are each particle is we are consisting of surface of charge distribution. So this surface of charge distribution effect on the electric field intensity. We can find out the electric field intensity. This distance we have taken as r dash. So what happened here? Only what will change is we can find out the small particle of distance. So rho into dl here, rho s into, these are the surface. We are consisting of surface, rho s into ds. So here dq is equal to the charge element. Here also same as charge element. Here we are consisting of ds. ds is equal to the element of length. It is not element of length. The element of surface or area. Element of area or surface. So next, they are the not a line charge, they are the surface charge. Surface charge. So again same as electric field intensity, the formula must be same. Here small part, so here also a small part of electric field intensity, small part of electric field intensity. So here what will change? Here dq is equal to rho l into dl in the previous case. Now here what is the dq? dq is equal to rho s into ds with respect to a or unit vector. So again same symbol, only we can change of rho s into ds. So this is for line, not a, it is a surface charge. Surface. Finite surface charge density. It is a finite surface charge density. It is nothing but surface charge distribution. Similarly, we can find out the, what is the last case? Volume charge density. Volume charge density. Volume charge density. So in this case we are consisting of volume of charge density. So volume of charge density again dq. So these are we are consisting of dv, and remaining these are the rho v. Only we can change of v and v, and we can change of rho s dv, rho v, and we can change of dv and rho v, dv and rho v. These are the not a surface, they are the volume charge. They are the volume charge. So up to here we discussed only electric field intensity due to the continuous charge distribution. We are consisting only finite distance and finite area, finite value. So next we discuss the infinity length, infinity area.